Welcome back to my channel. Today we will be discussing IP addressing. This is the network or internet which is layer 3 sa OSI model. This layer provides the logical IP addressing. IP version 4 is a 32-bit wide binary digits grouped into 8 bits called octet or byte. So kailangan natin maintindihan yan na 32-bit wide in binary na nakagrupo sa 8 bits. Now, what is an IP address? It is a unique logical IP address that identifies an internet or LAN connected device. Dito sa LAN topology natin, ginamit ko yung network ID na 192.168.1.0 with a network mask of 255.255.255.0. As you can see, each device has its own unique IP address. Ngayon, para na mas maintindihan natin yung IP addressing, you remember, it is a 32-bit wide binary grouped into 8 bits called octet or byte. So, kailangan natin maintindihan yung binary numbers. Binary numbers is counting by 2. So, you have 0 and 1 only as the symbols. Kapag ikunumpara mo sa decimal numbering natin, which is yun ang pangkaraniwang naiintindihan natin, makikita mo na every time na from 0 to 1 o every 2, nag-change siya, nagkakaroon siya ng, nag-move siya doon sa next significant bit niya. So binary counting is a power of 2. Meron akong create na table, which is table number 1. Pansinin kung paano ko inilabel yung group of 8 bits or 1 octet. I started counting from the right going to the left, with the leftmost best as the most significant bit. Just like when you are counting in binary, it moves to the left. The leftmost is the most significant bit. So yung unang row ay power of 2. So 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32, and 2 to the 6 is 64, and 2 to the 7 is 128. Mapapansin mo sa third row ng table 1, pag inad ko lahat yung quantity na yon from bit number 1 to bit number 8, yung total sum niyan ay 255. So kaya pag binigyan tayo ng decimal dotted format na IP address, the maximum number that we can get from there is 255. The fourth row represents the what? The CIDR notation. So the 192.168.1.1 will be slash 24. So because I started with slash 25, that means this is the fourth octet. Sa yung ika-apat na grupo ng 8 bits. Kasi nag-start siya ng slash 25, then slash 26, then slash 27, then slash 28, 29, 30, 31, 32. So na-fulfill natin yung 32-bit wide na binary digits. Let us take, for example, the address of the PC, which is 192.168.1.1 with a network mask of 255.255.255.0. This is the dotted decimal format. So if you want to have it in CIDR format or classless inter-domain routing, it will be 192.168.1.1/24. Paano ba nakuha natin yung in binary? Na-convert yung 192. 192 will be the sum of the 8-bit and the 7-bit, which is 128 plus 64. In the table, it is 192 there. You can see in the third row, under that there is 192. So yung 168, ang nag-1 na bit ay yung 128, which is the 8-bit. The 7 is 0. The bit number 6 is 1, which is 32. And then the next bit is 0. And the fourth bit is 1, which is the 8. So kaya pag ito-total mo yon, 168. The last two octet has only a value of 1, which is easy, which is the first bit will be 1. Now, the network mask is 255.255.255.0. Ibig sabihin nun, lahat ng bits dun sa octet, sa first byte or first octet, then the second octet and the third octet are all ones because sabi ko nga kanina, ang maximum value na makukuha mo in dotted decimal is 255. And the last octet is 0. Ang purpose kasi ng network mask, it provides the demarcation between the bits that is being used as a network and the bits that all 0, which is for the host. So in our case, the host, which is the fourth octet. So 32-bit wide. You can see from there, my counting is from the left going to the right, 32. Even by convention for the octet, the first octet starting from the leftmost, the second, and the third, the fourth. Being the fourth is the from slash 25 to slash 32. Now, paano mag-convert ng binary to decimal? So, ilalagay lang natin doon sa table, i-fit lang natin kung ano nag-1. Tapos, pwede nating i-add lang instead na i-multiply kung alin ang nag-1. So, dahil dito sa binary number na example natin ay 11000101, pag ilalagay natin yan doon sa table, makikita mo na yung first bit is 1. The second one is 0. The third one is 1. The fourth one is 0. The fifth one is 0. Yung ika-anim is also 0. Pero yung ika-pito at ika-walo, parehong 1. Pag inad mo yung nag-1 na mga bit, that will be your decimal number. So 128 plus 64 plus 4 plus 1 equals 197, which is the binary number 11000101. So addition lang ang ginagamit. Kapag naman magko-convert ka from decimal to binary conversion, subtraction lang. Madali rin. So bibigyan ka ng decimal number, ang gagawin mo ngayon ay isusubtract mo lang kung ano ang pinakamalaking maisusubtract mo dun sa numero na yon. So let's say yung 58, ano ba ang pinakamalaking maisusubtract mo dun? Is 32 because 64 hindi na pwede. Mas malaki na yung 64 kaysa 58. So if you subtract 32 from 58 equals 26. Sa 26, anong maisusubtract mo? Nasusunod ay 16. So, ibig sabihin nun, yung 32 at saka 16 magwa-1. So, 26 minus 16 magiging 10. Ano naman ang pwede mong isubtract uli? Yung 8. Magwa-1 uli ang place value ng 8. So, 10 minus 8 will be 2. So, ano ba? Lalagyan mo siya ng 0 kasi hindi siya pwede sa 4. So, lagi mong tatandaan. Susundan mo yung place value ng 2 ha. Huwag mong basta-basta na dahil 0, babaliwalain mo yun. Hindi. Kailangan mo masunod mo yun. Kasi remember that in an 8-bit or in an octet, bawat bit doon ay may significant. Diba? Starting from the right going to the leftmost, ang leftmost ay ano yun, most significant bit yun. Malaki ang value noon. 128 yung nandun sa 8-bit. Sa 7 is 64. So para hindi mawala yung ano yung conversion mo. Kung hindi ka pwede mag-subtract, lagyan mo lang ng 0. So, subtract mo yung susunod ka, okay na. Lagyan mo lang ng 1, i-trigger mo. Then, that's it. So, 58 will be binary 00, 111, 010. Yung table natin ay pinakita ko earlier, hindi yung nag-i-end doon sa 8-bit lang ha. Lalo pagka nag-compute na tayo ng host bit dito sa class A, hanggang 24 yon papunta rito sa kaliwa. Ang host nun. Pag i-translate ko na yung mga IP addresses nyo, makikita mo na ang host sa class A na IP address range is hanggang 24-bit. Ayan. Classful IP address. Ayan ang classification. You have class A, class B, class C, class D, which is multicast, and class E, experimental. Huwag tayo mag-concentrate muna dun sa class D at saka class E. Dito tayo sa class A, class B, and class C. Makikita mo, mapapansin mo, mayroon akong mga bit dun na inilagay kong red. Remember that my counting for the 32-bit wide binary digit is from left to right. So yung number 1 kong bit, makikita mo, naka-red, di ba? Sa class A. So ang range niya from 0 to 127. So take note about this range ha, because 0 is 0.0.0 is not used ha. This is not allowed. And the 127 is a special IP address used in testing the loopback. We will come to that later on the slide. Now, class B start from 128 to 191. Tignan mo yung bit na trigger doon sa hindi mo pwedeng galawin. 10, di ba? Yung 128 is 1, which is the 8-bit in an octet. Ha? Kasi ngayon octet yan dahil may dot. Group in 8 bits is an octet or a byte. 1 byte or 1 octet. Makikita mo na yung 8-bit or in an octet, kasi ang nilabel ko in an octet is starting from the rightmost going to the leftmost being the most significant bit. Pero dito sa 32-bit wide, makikita mo yung unang bit ha. Gamitin natin yung 32-bit. Yung unang bit, naka-red sa class A. Tignan mo, pag na siya, 0 to 127. If you add, which is the network part, it is only the first octet. Tingnan mo yung nag-1. From bit number 1 to bit number 7. If you add that, the 255 minus the 8-bit which is a place value of 128, magiging 127. Di ba? Pag nag-add ka pa ng 1, papasok ka na sa class B which is 128. Di ba? O, nag-1 ka na, nag-0 ka. Tapos, ang range na is 128 to 191. I-add mo lang yun. Pero ang network part sa class B ay dalawang octet. But the first octet, you cannot touch the first bit and the second bit. It should be 1 and 0. So kaya pag kinuha mo yung network niya, na lang ang network niya? 2 to the 14. 2 to the 14. Doon naman sa class A, 2 to the 7. Di ba? Ayun ang network niya. 2 to the 7 and then 2 to the 14 dito sa class B. Sa class C naman, tignan mo, yung sequence. Pag nag-add ka pa ng 1 doon sa last range ng class B, magiging 192. So, matitrigger mo na yung 128 plus 64 para maging 192. And then, the next to it will be 0. Kasi ang last IP address dito sa range na yan ay 223. If you add 128 plus 64 plus 1 plus 2 plus 4 plus 8 plus 16 is 223. That means yung 255, babawasan mo lang ng 32. Yun lang ang nawala dyan, yung 32, kasi 0 yun. So the rest, we will not be touching that one. So observe. Observe the range, how it changes. When you are trying to get the network number or the maximum network number in exponential form, which is in class A, it is 2 to the 7. You know, from 0 to 127, which is 128, diba? In class B naman, 2 to the 14th. Kasi hindi mo po pwedeng galawin yung kasi the same number from 0 to 223 galing yun dito sa first octet eh. Kaya nababawasan yung network part bit ng IP address. So yung N part refers to network. Yung H refer to the host bits in a class full network. So sa class A, ang H niya hanggang 24. Ang network part niya hanggang 7. Kasi as I was telling, 0 you cannot touch it because it will go to the next range. Diba? So N. That's why it is from 1 to 126 in class A. The network mask is 255.0.0.0. The dot 0 represent the host part in an IP address. Sa class B naman, it is from 128 to 191, 255.255.0.0. That means the host part is 2 octets, the fourth and the third. The network will be the first octet and the second octet. Sa class C, you have the network part 3 octets, the first, the second, the third, while the fourth is for the host IP addressing. Okay? So, wag mawawala. Kailangan tandaan natin na pagka class A, 0 yung unang bit doon sa 32-bit wide na IP address na binary digit, ha? 0 yung unang-una, yung pinakakaliwa. Diba? O kaya, para hindi tayo mawala, sasabihin natin yung 0 yung most significant bit dun sa octet, sa first octet. 32-bit wide numbering ko kasi, simula dito sa left, papunta sa right. Parang nakakalito. So, para hindi ka malito, sabihin na lang natin in an octet. Kasi first octet, bit number 8 is the most significant. So, in class A, 0 yon. So, how many bits only available for the network is only 7. The rest, the 24 bits is for the host. So, as you move to the class B, it changes. Because the 127, if you add another one, it will go to 128. That means the 128 is 1, the 64 is 0. And how many bits is allocated for the network? It is 14. 6 plus 8. 6 in the first octet and 8 bits in the second octet, while the third octet and the fourth octet are for the host. This is very important. We will have to deal with this one while we are in the IP addressing, specifically when we are going to the subnetting. Very important that one. Tandaan natin ang class A, ang unang bit o yung bit number 8 sa first octet is 0. Then the 8th bit and the 7th bit in the first octet for the class B is 10. While in class C, the 8th bit and the 7th bit are 1, with the 6th bit being 0. Nagagamit ng router yon. Later on, when we start working with the router, this is how it classify if that is a class A, a class B, or a class C. Immediately, it can determine what is the address type. Okay, let's move to the next slide. Private IP addresses. Alam mo yung private IP addresses, malaki ang naitulong niya para mag-slow down yung depletion ng IPv4 addresses kasi reusable. Pero itong private IP addresses range is not being used in the internet. It is not because it is not routable, it is being filtered. This is not allowed in the internet. So kapag ang purpose talaga ng private IP address is for individual network or for the private corporate network, and it can be reused by any other company. Walang problema doon. Kasi kapag ang yan ang range na ginagamit mo para ma-reach mo yung internet, meron isang ano pa dyan eh, meron pang isang services na kailangan mong matutunan, which is network address translation. So you are using a private IP address, and kung tutuusin, wala kang reachability sa internet kasi this IP address range is not allowed in the internet. So for class A, you are allowed to use 10.0.0.0 with a network mask of 255.0.0.0 to 10.255.255.255 with a net mask of 255.0.0.0. So walang problema yung range na yan, pwede magamit ng mga corporate yan. Sa class A, kung ang requirement mo pagdating sa host or usable host IP addresses is malaki, use the class A. Pag medium size ka, at kukunti lang naman ang host mo, use the class B. And the range for class B, it is 172.16.0.0 255.240.0.0 to 172.31 255.255 with a network mask of 255.240.0.0. And there is another one IP address which is 169.254.0.0 with a network mask of 255.255.0.0. And lastly, the class C, the available private IP address is 192.168.0.0 to 55.255 to 192.168.255.255 with a network mask of 255.255.0.0. So kung iyan ang ibinigay sa atin ng mga private IP addresses, the rest are public IP addresses, which is used in the internet. Also remember, presented to you the class A, it starts from 0 to 127. However, you cannot use the 0.0.0.0 with a net mask of 0.0.0.0 because ginagamit kasi yan na router as a default route. Yun naman 127, it is used for loopback IP addresses for testing your network card. Kapag halimbawa nag-install ka ng network card doon sa PC mo or sa laptop mo, gusto mong matesting without going to the network, the functionality of your protocol stack, you just ping 127.0.0.1. Kapag may reply ka na doon, okay na yung device driver mo, okay na yung card mo na in-install mo. Then, how do we assign an IP address, by the way? There are three ways to assign an IP address to the device. One is statically. That means the network administrator, the technician, the people who are supporting the network will have to go to each client and assign the IP address. Napakahirap nito pagka marami yung devices niyo kasi imagine kung let's say meron kang isang bilan na meron kang 254 devices connected to the LAN, you have to go to each device 254. So pagka ang assignment ay statically, mataas ang administrative overhead. Yung proper na mas convenient gamitin ay using Dynamic Host Configuration Protocol or DHCP. Wherein you define the network scope, the network mask, the default router, your DHCP server IP address, and your DNS server IP address and other parameters. The third one is automatic private IP addressing. It will get an IP address in this range 169.254.0.0 with a network mask of 255.255.0.0. It only happens when the client you connected to the network and it was looking for the DHCP server. When it did not get a reply from the DHCP server, it will assign automatically this range. And also, this is not reachable in the internet. Ngayon, hindi ko muna i-discuss yung ano, pero meron akong gustong ipakita na number system na available also. Pinakita ko sa iyo earlier is decimal and binary. There is another one with another two, hexadecimal and octal. Hexadecimal is counting by 15. So notice it. When you start getting the 10, instead of 10, it is A, B, C, D, E, F, which is 15. Kasi makikita mo itong alphanumeric characters in a MAC address of the device. Once we start discussing about the LAN, baka magtaka kayo kung saan nakuha yung mga yung alphabet A, B, C, D, E, F. Kasi yung MAC address is represented in hexadecimal. Octal is also there, but I haven't seen any use for the octal. I think it is being used by another system. So at least you will know that there is hexadecimal, there is binary that is being used in the data network. Okay? Hanggang dito lang muna. Susunod natin ay yung siguro yun na tayo sa subnetting. Medyo mas mahirap-hirap na uli. Salamat.